Hello everyone, in today's video lesson we'll be working on solving systems of equations using substitution and elimination. So we're going to go ahead and start with substitution. Substitution is beneficial when it is difficult to find an exact solution by graphing. So if your graph isn't very clear or you can't really see what's going on, you're going to need to use a different method. Substitution is a good one for that. So there are 5 steps to solving a system of equations by substitution. Step 1, solve for one variable in at least one equation if necessary. 2, substitute the resulting expression into the other equation. 3, solve that equation to get the value of the first variable. 4, substitute the known value into one of the original equations and solve for the other. And 5, write the values from steps 3 and 4 as an ordered pair, x, y, and check. So we're going to go ahead and go through this step-by-step process in our first example. So I have example 1 and step 1, solve for one variable in at least one equation if necessary. So I have these equations, y is equal to 3x minus 8 and y is equal to x plus 2. And neither of those things need to be rearranged because we have one variable equal to something else, so we can use that. So we're going to go ahead and move on to substituting one expression in for the other. So in this situation, I'm going to take my y of 3x minus 8 and I'm going to plug it in for the other y. So instead of y, I have 3x minus 8 equals x plus 2. Then, continuing in that step, we are solving that equation to get the first variable. So we're solving for x. That's going to give us our x. So I have 3x minus 8 is equal to x plus 2. I want x by itself. I'm going to start by adding 8 to both sides. So I have left on that side, 3x is equal to x plus 10. I'm going to subtract out this single x from both sides. That leaves me with 2x is equal to 10. I'll divide out the 2, which means that x is equal to 5. And that is part of my solution. Okay, so that was steps 2 and 3. Step 4, substitute the known value into the original equation and solve for the other value. So we're now going to solve for our y. So I'm going to go ahead and take my x and plug it into one of these two equations. I'm noticing that this second equation is going to be the easier one to solve with. There's less steps there, so that's the one I'm going to use. So I have y is equal to x, which is now 5, plus 2, which means y is equal to 7. That's step 4. Then step 5, you're going to write these two things together in an ordered pair. So I have an x of 5 and a y of 7. So my answer is 5, 7. That's my answer. And to check to make sure that works, we're going to plug in and solve. We already know it works here. We're going to take our x and plug it in here. So I have 3 times 5 is 15. 15 minus 8 is equal to 7. That works. It checks out. It works for both of them. And you should be writing down the checking step. I'm not going to here. I'm not going to be grading you on that, but you should be writing it down. It will definitely help you out if you're unsure of your answer. So again, to check your work, you take your x and you plug it in the second equation. If you get the same answer, your work checks out. Alright, let's take another example here. So example 2, we have solved the system below by substitution. I have 2x plus y is equal to negative 4 and x plus y is equal to negative 7. In these equations, neither one of them has a variable by itself on one side. So I'm going to have to rearrange one of the equations. I'm going to go ahead and rearrange x plus y is equal to negative 7. I'm going to subtract out the y from both sides. That leaves me with x is equal to negative y minus 7. Now I'm going to take that and I'm going to plug that into my other equation. So I have, instead of, by the way, these steps are color-coded. So step 1 is orange, step 2 is blue, so is step 3 because those two things go together, and so on. So I'm now going to substitute this into my other equation. So I have 2 times, instead of x, I now have negative y minus 7 plus y is equal to negative 4. I'm going to distribute this out. So I have 2 times negative y, that leaves me with negative 2y, minus 2 times 7 is 14, plus y is equal to negative 4. I'm going to add 14 to both sides, and I'm also going to combine my like terms all in one step. So I have negative 2y plus a positive y gives me a negative y. So I'm adding 14. That gives me negative y is equal to 10. Negative 4 plus 14 is 10. I do not want to have a negative y, so I'm going to divide out negative 1, which means that y is equal to negative 10. So now that I have that, I can go ahead and plug that into my second equation. So I'm going to plug that in. I'm actually going to plug it in down here. So I have x is equal to negative y, and our y is negative 10, minus 7. And I have negative of negative 10, which means our negatives cancel out. So I really have 10 minus 7, which means that x is equal to 3. So now we're going to take those two things and we're going to write those in our ordered pair. So I have x is 3 and y is negative 10. Now we're going to check that by plugging in both of those things into the first equation, and it should equal a true statement. So these added together should be negative 4. So I have 2 times x, which is 3. So I have 6 plus negative 10 is equal to negative 4. So that checks out. Alright. We have a couple more substitution questions here, and they get a little more difficult. Now, this first one, everything is rearranged for us already, so we don't have to do that step. We just have to plug something in. But if you notice, there's a fraction in here, which tends to give some people some trouble, so that's why we're going to look at one of those. So I'm going to take my 2x and plug it in for y, so I end up with 2x is equal to 1/2 x minus 3. I'm going to subtract out this half of an x from both sides. So I'm subtracting out half x. So 2 wholes minus the 1/2 leaves me with 1.5 x. That's 1.5x, or 1 and 1/2 x. So I have 1 and 1/2 x is equal to negative 3. It'll actually help me out if I write this as an improper fraction. So I have 1 and 1/2, so 1 times 2 is 2, plus 1 is 3, so what I really have is 3/2 of x. And to get rid of that fraction, I'm going to multiply both sides by the reciprocal, which is when a fraction is upside down. So I'm going to multiply both sides by, instead of 3 over 2, it's now 2 over 3. Although I wrote that wrong, so let me fix that. 2 over 3. We're multiplying that on both sides. This is also the same as dividing on a fraction. So I have x is equal to negative 3 times 2/3. When you're multiplying fractions, this is like negative 3 over 1, and then you multiply straight across. So I have negative 3 times 2, which is equal to negative 6. And 1 would be on the bottom, so our denominator would stay the same, so that's over 3. Negative 6 divided by 3 is equal to negative 2. So x is equal to negative 2. Alright, so that is the long route of doing that by hand. That's what happens with your fraction. So then after this, the process would be the same. You would take that and you plug it into one of these equations, preferably one that's going to make your math a little easier, and then you're going to check your work. So I have x is negative 2, I'll plug it into this one. So I have y is equal to 2 times negative 2, which means that y must be equal to negative 4. So my system, the solution to my system should be negative 2, negative 4, because, just a reminder, a solution to a system of equations is an ordered pair. So that is my solution, and then we can check that too. So negative 2 times 1/2 is equal to negative 1 minus 3 is negative 4, so that does work out. And one more example here. I'm not going to go through this whole example, I'm just going to help you get it set up. So it'd be the same thing here where you would rearrange if you need to, but we don't because we already have something that x is equal to. Then you would take this and you're going to plug it in. So we would have, for our first line, 3 times, instead of x, we have 6y minus 11 minus 2y is equal to negative 1. And from here, it's all the same. So we would distribute, simplify, solve for y is what you're doing. Then you're going to take your y and you're going to plug it into one of these equations to solve for x, and that will be your solution. Alright, so now that we've looked at substitution, we're going to take a look at solving by elimination. So elimination is kind of like substitution, where we want to get one variable by itself so that we can substitute it back in. And we only have 4 steps though. So we have step 1, write the system so like terms are aligned. 2, eliminate one of the variables and solve for the other variable. 3, substitute the value of the variable into one of the original equations and solve for the other variable. 4, write the answers from steps 2 and 3 as an ordered pair, x and y, and check. So we have an example here, we have 5. Example 5, solve the following system by elimination. So I have 3x minus 4y is equal to 10, and x plus 4y is equal to negative 2. Step 1 was to write these so that our variables are aligned. My x's are already in place, my y's are vertically aligned, and these don't have a variable, so we're all set up there. Then step 2 said to eliminate one of the variables and solve for the other. So what that means is we're going to take these equations and we are looking so that we have one of these variables that will cancel out when you add them together. So I have negative 4y and positive 4y. Negative 4 plus positive 4 is 0, so that would cancel out, which means that this is going to work out. We don't have to change anything. So the first thing I'm going to do is add those two equations together. That gives me 3x plus x is 4x. Negative 4y plus 4y is 0, it cancels out. And that's equal to 10 plus negative 2, which is equal to positive 8. Now I have something that I can solve for x with. So I have 4x is equal to 8. Divide out the 4 from both sides. X is equal to 2. So now that I have x, I can take that and I can plug it into one of these equations and I can solve for y. So I have, let's use the first one. There's not any particular reason. This is step 3, by the way. You can use either one. It does not matter. You just have to pick one. So I have 3 times x, which is 2, minus 4y is equal to 10. 3 times 2 is 6. So I have 6 minus 4y is equal to 10. I'm going to subtract 6 from both sides, which gives me negative 4y is equal to positive 4. I'm going to divide out negative 4 from both sides. And that leaves me with y is equal to negative 1. Now that I have those two things, I can write those in my ordered pair. So I have 2 for x and negative 1 for y, and that is my solution. Then I would want to check it, and to check it, I would take the x and I'd plug it into the other equation. And then you can plug the y in too. So I have 4 times negative 1, that's negative 4. So I have 2 plus negative 4 is equal to negative 2. That checks out, it works. Alright, let's go ahead and take a look at another example on the next page. Okay, on this page, we're actually going to go ahead and skip this first example, and we're going to look at a couple where you have to do some setup. So this example here, we have x plus 2y is equal to 11, and negative 3x plus y is equal to negative 5. I'm noticing that these things are already vertically aligned, so I don't have to rearrange the equation, but I am noticing that negative 3x and positive 1x, those don't cancel out, and 2y and positive 1y, those don't cancel out either. So I have to multiply one of these equations by something to make it cancel out. So if I need 2y to cancel out, then I would need the second equation to have a negative 2y, because 2 plus negative 2 is 0. So this would have to be a negative 2y. And that's pretty easy to accomplish. We just have to multiply this bottom equation by negative 2. The whole equation we're multiplying by negative 2. So I'm going to take that equation, I'm going to multiply the whole thing by negative 2, and then I'm going to rewrite that over here. So I'm going to start by rewriting my first equation above it. So I have x plus 2y is equal to 11. Now I'm going to multiply this whole thing. So I have negative 2 times negative 3x. Those are both negative. A negative times a negative is a positive, so that gives me 2 times 3, which is 6. So I have 6x plus negative 2 times y is negative 2y is equal to negative 2 times negative 5 is equal to positive 10. Now I can take those two things and I can add them together. So I have 7x, my y's cancel out, is equal to 11 plus 10, which is 21. I'm going to divide both sides by 7. That gives me x is equal to 3. So there's my first equation. Now I'm going to take that and I'm going to plug that into one of these two equations, or you really could use the one that we multiplied by, but this is the reduced form, so that would be easier to work with. So I'm going to pick one of those to plug it in. I'm just going to plug it into the first one. So I have 3 plus 2 times y is equal to 11. I'm going to subtract 3 out from both sides. 2y is equal to 8. Divide out 2 means y is equal to 4. Now I'm going to take those two things and I'm going to write those in my ordered pair. So I have 3, 4 as my solution. Alright, we have one more example here. Example 8 says solve the following system of equations by elimination. And much like before, we have everything lined up, but nothing that's going to cancel out. Negative 5x and 2x, those don't cancel. 2y and 3y, those don't cancel. So if I'm looking at these and I'm trying to figure out what would be easy to move, nothing that I can multiply by 2 is going to equal 3, and nothing I can multiply by 2 is going to equal negative 5, which means that I'm going to have to multiply both of my equations in this situation. So if I want these to cancel out, I need to find something. I already have a negative 5, and so then I wouldn't have to multiply anything by a negative. So if I get rid of my x's, then I can multiply both things by a positive, so that would be helpful. If I multiply 5 by 2 and 2 by 5, then we'd have a negative 10 and a positive 10. So that would make things cancel out nicely. So that's what I'm going to do. I'm going to multiply the top equation by 2. I'm going to multiply the bottom equation by 5. So I have 2 times negative 5, which is negative 10x, plus 2 times 2y is 4y, is equal to 2 times 32, which is 64. Now we're going to complete our multiplication of our second equation, which we're multiplying by 5. 5 times 2x is positive 10x, plus 5 times 3y is equal to 15y, is equal to 5 times 10, which is equal to 50. Now I'm going to take those and I'm going to add those together. So I have negative 10x plus 10x, those cancel. 4y plus 15y is equal to 19y. 64 plus 50 is equal to 114. So now I need to divide out 19 on both sides, and that gives me that y is equal to, we're going to check that. So I have 114. So I have 114 divided by 19, which is equal to 6. So y is equal to 6. Now I can take that and I can plug that into my second equation, or really any equation. We have 4 options now. Again, if you pick one of these original ones, your math is going to be nicer. So I'm just going to pick this equation here. So I have 2x plus 3 times y, which is now 6, is equal to 10. 3 times 6 is equal to 18. So I have 2x plus 18 is equal to 10. Subtract out 18 from both sides. 2x is equal to negative 8. And now I'm going to divide out the 2 to get x by itself. So that means that x is equal to negative 4. So we take that and we write that in an ordered pair. Negative 4, 6. And that is my solution. I do need to check it. So to do that, I would plug my y into my other equation, and I can plug my 4 in as well. Negative 5 times negative 4 is equal to a positive 20. 2 times 6 is equal to 12. 20 plus 12 is equal to 32. That checks out. Alright, so those are the 2 other methods, elimination and substitution, for solving for a system of equations. So just to recap that, for graphing, use when both equations are solved for y and you want to estimate a solution, you graph them and find the intersection. For substitution, they're useful when a variable is either equation has a coefficient of 1 or negative 1, and both equations are solved for the same variable, and either equation is solvable or is solved for a variable. And elimination is useful for when both equations have the same variable with the same or opposite coefficients, and a variable term in one equation is a multiple of the corresponding variable term. Or a variable term in one equation is a multiple of the corresponding variable term in the other equation. So those are when it's best to use them, but you can use them for any of them. You just might have to do some rearranging to make it work. Alright, so that is where we're going to stop. We'll pick back up with a few special situations and some word problems in our next section.